So let's see how we would calculate this magic number. We have a formula for the benefit as a function of quantity, which is right here, 250q minus 4q squared. And then we have an expression for the cost, again, as a function of quantity, and it's q squared. So the net benefit is the benefit minus the cost, similar to profit equals revenue minus cost. And here we put them together. So net benefit as a function of quantity equals this expression, which is the benefit or the revenue, minus this expression, which is the cost. And all we have to do is solve that and say, what's the slope of that? Oops, we can't do that yet. Well, some of you know what we're looking at because you have some calculus in your blood, but not everyone has calculus, or if they had it, they may not remember it. So we're gonna introduce you to a very, very simple formula or calculation that we do in calculus. All right, I'm not going to teach you the whole field of calculus, just as one thing. All right, so let's look at that. This is calculus for non-math people. So if you're an engineer, you can tune out for a minute or two. If you're not a math person and you're scared, don't be scared. Just listen, and I think you'll get it. So the slope of an expression is determined by the first derivative, and that's what we call it in calculus. Now we have two scary words. We have calculus and derivative. But let's go into it, and I'm just going to show you the mechanics. To show the mechanics are quite simple, at least in the scope of the work we will do in managerial econ. So this is what we've been dealing with. We derived this formula, and that's where we got stuck, because now we have to know the slope. So we now know this formula, and notice that unlike a straight line, it changes. So as the q changes, the slope changes. That's why it's a curve. If we're a line, it'd just be a straight line, and we know the slope is constant from 0 all the way up to infinity, right? They have a constant slope. That's one of the beauties of a straight line, is the same slope for the entire range. However, now we have this moving target. So how do we calculate this? So we're going to do this with the use of calculus. So this, again, might look a little scary, but I'm doing this to show you that mechanically, again, not theoretically, but mechanically, it is very, very easy. So if I have a hypothetical formula, which is y equals 3x squared minus 4x to the first power, which is just x, plus 12, we can then do the first derivative by doing a little bit of calculus. Here, the expression is dy dx, which means it's the derivative of y with respect to x. That's all that notation means. And what we do mechanically is notice that we take the 3 from the coefficient, the constant right in front of the first variable, stick it right there. Then we take the power or the exponent of that variable and stick it right there. So now that's in front of the x. Then we write x, and then now we reduce the power by 1. So it's 2 minus 1 is there. Then here we preserve the minus sign right there. And then we do the same thing. What is the constant in front of the variable? It's 4. And then what is the power? It's 1, x, and then 1 minus 1. And then notice that this has no x. It does not change on the dimension of x, so it goes to 0. So constants, like 12, have a value of 0 when we compute slope. So from there, we're just simplifying the math we just did. So 3 times 2 is 6. X just carries through. 2 minus 1 is 1. Minus, always remember signs, 4 times 1 is 4. Carry down the x. 1 minus 1 is 0. And we could simplify again to get to the final expression, which is 6x, because x to the first is just x. There's no x times x. That would be x squared. It's just x, so it's 6x. And then x to the 0 power is equal to 1. So 4 times 1 is 4. And that's what we do. And here are the steps. I wrote them out, but I explained it to you. Hopefully, either from my explanation or reading this and trying it out, you'll see that you can do it. I've done this many times with students and have shown the non-believers that calculus, at least for a first derivative, is not very difficult for the types of work we're going to do in this course. All right, so you follow mechanically these steps and take your time, but if you do that, you will get it correct. Let's see if we can do it. So let's solve this problem. So we have this expression that the net benefit with regard to quantity is equal to 250q minus 5q squared, and let's go to Excel. Just copies both the formula and kind of the steps, so again, for your reference later on. So we're going to solve for where the slope is 0, because remember we want to hit the peak, and at the peak its slope is 0. And we have this expression. I just carried it down here. So let's do the first derivative. All right, let's start. So I'll just start and do exactly the mechanics we have on the left. So I'm going to say, okay, what's the first coefficient or constant in front of the variable? It's 250. And then times, what is the exponent of the first one? Oh, it's just q. That means it's 1. And then the variable itself, q. And it's going to be raised to the power, I'll just do caret, raised to the power of what? It's the exponent, which is 1 minus 1, right? Right? And then we carry the next factor, which is minus, and it's, again, 5 times what? Here it's squared, so it's 2. Carry the variable q, and then it's going to be raised to the power of the exponent, which is 2 minus 1. All right, so I'm doing this in Excel. A lot easier on paper and pencil, believe me. But let's now solve it. So 250 times 1 is 250. The variable is q, and it's going to be raised to the power of 1 minus 1, which is 0, right? Raised to the power of 0. I'll just do it nice and slow. Minus, what's 5 times 2? Oh, I got that. It's 10. Q. And it's going to be raised to what power? 2 minus 1. Oh, that's easy. It's 1, right? So now we can finalize and say it's 250, and q to the 0 power is 1, so it just disappears. The variable disappears. Minus 10 times q. Q to the 1 is just q. So that's our expression. And now we can go solve it. You say, okay, let's take that and set it to be equal to 0. And let's solve it. So that means 250 equals 10q. Therefore, q equals 250 divided by 10 equals 25. So the answer here is the optimal point for this particular equation or set of equations that we turned into one net benefit equation is 25. So at that point, you've hit the peak, and anything less will earn you less money. Anything after earn you less money. But exactly at 25 is your optimal level of production or sales in order to reach maximum benefit.